Hey everybody, welcome back to another fun and exciting algebra class. Today we are going to be jumping into lesson 11.7. That's adding and subtracting rational expressions when they have a different denominator. We're going to use what we talked about in the last lesson about finding the LCD. This is on page 429 in your books, page 429. All right, let's just jump right into it. We got a busy lesson here. So what we want to do is we want to talk about adding and subtracting when they have different denominators. So first thing that we need to do, step number one, is we need to convert the fractions to fractions with the LCD. That's what we did in the last class, okay? Step number two, we want to rewrite the fractions as one fraction over the LCD. That's what we did 2 classes ago when we were talking about how to add these fractions. Number 3, again, same as we did. Here's the great thing about this lesson. This lesson, there's no new material in this lesson. It's just a combination of the last 2 lessons, okay? Step number 3, we are going to combine the terms of the numerator. Make sure to carefully follow the signs. Step number 4, we want to cancel all common factors. Step number 5, we want to set those factors. I wrote factos again. Let me change that. I won't change that. Last time I didn't change it. Factors. There we go. Set the factors equal to 0. And then number 6, we want to write the remaining fractions with the excluded values. Okay? So again, this is just combining 2 different lessons that we've already done. Combining the lesson from I guess it was 11.5, where we did adding and subtracting, and then the lesson from 11.6, where we found the least common denominator. All right, let's just start on it. Let's just see what happens here. Let's see how you guys do with this. I'm going to start off with a really basic question right here, okay? This one has no letters in the denominator, so it's going to be quite easy for us to find the LCD, I think, all right? So our numbers are 15, 3, and 5, okay? And again, if I had it like this, if I had, 2 over 15 plus 3 over 5 plus 2 over 3. Okay, I think you pretty easily would know that the LCD is 15, right? We got to take all those to 15. Okay, 3 goes into 15, 5 goes into 15, 15 goes into 15. All right, so that's what we used to do when we were in baby math classes, and now we're going to do it a little differently. The only difference is we're going to keep them lined up horizontally instead of lining them up vertically. But our LCD is 15, okay? So what we need to do is we need to convert all of these into fractions with 15 as the denominator. Okay. How do we do that? Well, we say, what does it take for 15 to get to 15? Well, multiply by 1 or identity. So on this one, we just do the same thing. Multiply by 1, 2x. Nothing changes in that one. 3 times what equals 15? Well, 3 times 5 equals 15. So x times 5 equals 5x. 5 times what equals 15? 5 times 3. 3x times 3 equals 9x. Now, that's all what we did in last lesson. Now, let me show you something right here. This lesson, we now have addition signs right here. So what we need to do is we need to add all of these fractions together. Let's go back up to our steps. Notice it says rewrite the fractions as one fraction over the LCD. So now, instead of writing them all like this, let's write them like this, with 1 LCD over 15, okay? And so how do we write these numerators? Well, we write 2x plus 5x plus 9x. 2x plus 5x plus 9x, okay? And now what we want to do is we want to just combine those. We'll go up to our steps, cancel all common factors, set the equal to 0. Step number 3, sorry. Combine the terms of the numerator, carefully following the signs. All right, so we just follow the signs here. 2 plus 5, 7, plus 9 is 16x over 15. We don't have anything canceling out in the denominator because we don't have any letters down there. So that is our answer, 16x over 15. Okay. All right, let's take a look at this next one. We have 3 over x plus 1 plus 2 over x minus 3. First thing we want to do is find the LCD, the least common denominator. And on this one, we don't have anything common, so we're just going to say the LCD is x plus 1, x minus 3. We're just going to take both of them. Why? Because nothing is common there. So we're going to make new fractions, x plus 1, x plus 3, and x plus 1, minus 3. Sorry about that. Change that over here. There we go. And now what we want to do is we want to say, okay, what did I multiply by to get that? So what did I multiply by this x plus 1 to get x minus 3? Well, I had to do the x minus 3 times that. So I'm going to do this. 3 times x minus 3 plus, there's the plus sign. And then I would ask myself, on this one, what did I multiply by to get this? Well, I have the x plus 3, x minus 3, x minus 3. I had to multiply by the x plus 1. So now I had to multiply that times 2. So I'd have 2 times x plus 1. That would be my new numerator. Let me erase this stuff so you can see it a little bit better. Now, this is what I do. You can do it however you want here, but to me this is easier if I go ahead and I distribute, and at the same time I kind of combine these all into one fraction. So let's try to do those 2 steps, really kind of 2 steps, but let's do them together. So our common denominator is x plus 1, x minus 3. We only need to write that one time. We don't need 2 fractions. So we're going to combine them into one fraction. So how do we do that? Well, distribute the 3x to the x, and we get 3x. Distribute the 3 to the negative 3, and we get minus 9. Plus sign. Distribute the 2 to the x, and we get 2x. Distribute the 2 to the 1, plus 2. Sorry. There we go. Now what we want to do is we want to combine our like terms. And so we have like terms of 3x and 2x. So that's going to give us 5x. And then we have like terms of negative 9 and 2. So that's going to give us negative 7. And that's all still going to be over our common denominator of x plus 1, x minus 3. We would check this to see if there's anything that we can factor out, see if there's anything that we can do up there. There's not, so that is going to be our answer, x plus 5, x minus 7. Okay, and that's in your book. That is on page number 430, page 430. All right, let's try this one. It looks just a little bit different than the other ones, and let's kind of talk through what's going on here. Well, we have one that has a fraction in it, but we have 2 terms that do not have fractions. Well, how about, do you remember this when we were doing baby math? If we had 15 minus, 3/4, how did we do that? Do you remember? We had to turn this into a fraction. We had to borrow this down to a 14, and then we had to make that 4 over 4, right? Okay, now we can subtract it because we turned that into a fraction. Same thing is going on here. We need to turn those whole numbers into fractions so that we can add and subtract, because if they don't have a common denominator, then we can't add and subtract them. So here's what I want you to do. Just put them over the number 1. Okay? And so now they have a denominator. Anything over 1 is always itself. So if I have 7, I can put it over 1 and it doesn't change the value. So let's look at this. Now what would I do? Well, we still need to find the LCD, right? Okay, because we can't add these because they have different denominators. So let's look at what would the LCD be. Well, I have an x minus 1, and I have a 1 and a 1. Just like in any fraction, you could multiply by the 1, but it's not going to change anything, right? Because 1 is identity. So the LCD is just x minus 1. That's all I need for the LCD. Now what I want to do is I want to make a new fraction with x minus 1 for all of these. And we're going to add all of those together. So what did we have to multiply by here to get to x minus 1? Nothing, or 1, so this one just kind of comes down. What did we have to multiply here to get to the x minus 1? Well, x minus 1, because we had a 1, and now we have x minus 1. So how did we do that? We multiplied by x minus 1. Now we need to multiply the 2x times that, so we're going to get 2x times x minus 1. What did we have to multiply here to get to our x minus 1? Well, x minus 1 again. Multiply the 3 times that, we're going to get 3 times x minus 1. So there's our new fractions. All of them now have the LCD of x minus 1. Now we need to combine them into one fraction with x minus 1 as the denominator. How are we going to do that? Well, let's just write all of this stuff here at the top with the plus signs. X plus. Now we can distribute that. 2x times x is 2x squared. 2x times negative 1 is negative 2x. Plus 3 times x is 3x. 3 times negative 1 is negative 3. All right, so there's our new fraction with all of that kind of compressed down into one fraction. Now what do we want to do? We want to combine our like terms. I always start with the biggest exponent. I don't start with this right here. I don't start in order. I go find the biggest exponent because that one's going to go first when we write it. So there we go. Well, we don't have anything to combine with that, so we'll just write it down here. 2x squared. And then I would go to the next one, and there's a bunch of x's. So there's an x, and there's an x. Actually, let me take the sign with that. So x plus negative 2x gives me negative 1x. Negative 1x plus 3x gives me positive 2x. And here is a constant term, minus 3. And all of that is over our LCD of x minus 1. Now, we're not done with this one yet. This is why I wanted to do this one, because this one kind of gives us our next step. And we've done this before. And what we need to do now is we need to factor our numerator to see what we can do. Can we do anything else? Well, let's factor this numerator and see. What do we get? How do we do this? Well, we factor it and we get 1 times 2 and 1 times 3. And we're trying to get this 2x in the middle. So let's try that. X, we have minus plus as our signs. So one of these x's has to be a 2x, and one of these is a 1, and one of these is a 3. I don't know which one. We're going to test. We're going to find out what we can do here with our factors. So let's test it out. So that gives us 3x. That gives us negative 2x, and not quite. Okay, that gives us x in the middle, and we need 2x in the middle. So let's try to factor that again and see if we can get it to give us the numbers we need. Let's try to switch the 3 and the 1. Let's see what happens there. 3 and 1. Okay. All right. So here we go. And we get 1x. And here we get minus 6x. No, that gives us minus 5x. Now we can keep trying things here, but what you're going to find out is that this cannot be factored. Okay, it's not factorable. So we can keep trying things, but you're going to find out that there is no way. This is what's called prime. Okay, when it can't be factored, it's called prime. So all we're going to do is just circle this because there's nothing else that we can do. Now I wanted to show you that one because maybe we're going to have to cancel something. Maybe we're going to have to factor it, but in this case, not always does it work out for us. Sometimes we do, sometimes we don't. Let's do one more. This one has a subtraction sign, so I'm kind of looking forward to that. something new that we haven't done yet. First option is still find the LCD, okay? And that's important. So what is the LCD? Well, this one's already factored. This one's already factored. We need to factor that one. All right, we're going to get, this is a difference of two squares because we have two squares and a difference. So this is going to give us a conjugate. It's going to give us x plus 3 and x minus 3. Well, look what we have. We have an x plus 3 and an x plus 3. So that's part of our LCD, x plus 3. We have an x minus 3 and an x minus 3. So that's the other part of our LCD. So there's our LCD. Now, I'm going to erase this so that you can just see this, and I'll write it in there, x plus 3, x minus 3. I like to write the factored form in there. It's just easier for me to see, okay, when I'm getting my new fractions. All right, so I'm going to take my LCD, and I'm going to put it down here under each one, x plus 3, x minus 3, x plus 3, x minus 3, and under this one, x plus 3, x minus 3. Okay, and these are all the denominators. And now we need to rewrite these in our LCD form. So what did I multiply by to get this LCD? I had to multiply by, look, the x plus 3 is there, so I'm missing, or I had to multiply by the x minus 3. 1 times x minus 3 is x minus 3. Now, this one is important, so let's wait on that for right now. Let's just put the negative sign right there. We're not going to do anything with that, okay? We'll come back to that here in a second. Notice that we have an x plus or x minus 3 and an x minus 3. So what did we have to do there? We had to multiply by x plus 3. It's a 1, so it's just going to be x plus 3. I'd put that in parentheses if I was you. All right. And then this last one, we didn't have to multiply by anything. So the 2 just comes down, the 2x. Okay. All right. Now what we want to do is we want to transfer this, all of this, and make it into one fraction. What's our one fraction? Well, it's going to be over x plus 3, x minus 3. That's our common denominator. X plus 3, x minus 3. All right, now again, we do have to be very careful. This actually should have a plus sign in it. We have to be very careful of this negative sign right there. Okay, that can mess us up. So how do we do this? We want to just bring down our fraction. Okay, and so we have our x minus 3 minus, now you can do it however you want it here. I kind of like to distribute it as I'm bringing it down. So x, that minus goes into the x, so it's going to be minus x minus 3. Notice that my x gets a minus and my 3 gets a minus. Why? Because I distributed the minus sign. And then here's the plus sign and 2x. All right, so there it is into one fraction. Now we just really have a couple steps left. What we want to do is we want to combine all of our like terms. So let's put the fraction back down there again, the common denominator. And what we want to do is just start going. So x minus x and 2x. So x and minus x are going to cancel. We're just going to be left with 2x up there. There's a negative 3. There's another negative 3. So that's going to be negative 6 up there. Okay. Oh, now this one, we finally get one that we can do something with this. We can factor this out. Look what I have up there. Let me put parentheses on all these. I can factor out the 2. So I'm left with 2 parentheses x minus 3 parentheses over x plus 3, x minus 3. All right, check out what happens now. I can cancel that x minus 3 and that x minus 3. So here's my answer, 2 over x plus 3, and then I have to, don't forget that you have to set that equal to 0. X minus 3 equals 0. Move the 3 to the other side, and I end up with x cannot equal positive 3. So that's part of my answer. That goes along with that right there. So 2 over x plus 3, and in this case, x cannot equal 3. Why not? Because if x equals 3, then it's going to be a 0 in the denominator, and it's going to be a math error. We can't have that. Okay? All right. Wow, that was a lot of fun, I know. And it's a lot of work. You're going to have to really pay attention to those steps. Write those steps down. Follow those steps. Keep looking at those steps. It's very important that you pay attention to the steps when you're doing this more complicated algebra. Okay? All righty. We'll see you later. You have a good one. Bye-bye.